Well, hello everyone. I am going to test the equipment first, make sure everything is working properly. I just finished a 2.5 hour stream for my regular series, which I'm covering the Book of Proof, and I ran into some issues there. My trigonometry knowledge is a little spotty in places. I know enough to where to do the class, but what happened was I got caught up in trying to prove certain aspects of the. Basically, I was doing the unit circle and for my purposes, basically x squared plus y squared equals 1. Anyway, long story short, I got so annoyed with myself about unable to prove something I was trying to prove. I'm like, okay, you know what? I'm going to go nuts. Yeah, I do things for the pettiest reasons, and this was a petty reason, and I'm going to open up a new front. I'm going to now work on both books. This is Algebra and Trigonometry. A little bit about myself, since this is the first stream. I am a college student. I go to Westchester University. This semester, I'm just testing right now the equipment. I am on break this semester because of work. So I took the semester off. I work as a landscaper slash handyman. I still teach figure skating twice a week. And this right here, I'm doing mostly for my own benefit in the sense that when you have a live audience, you're forced to think that much harder to present it to people. And it really puts you on the spot. You can't just say, well, I'm just going to blow this off now. I'm tired or whatever. You're forced to finish. So let's get started. Let's do this. Anyway, this was the previous stream. And now I'm going to start up the new thing. And this book, you can download it in the description. It is part of the OpenStax project, which aims to provide open source textbooks that are free to download. Yeah, so if you go in there, click on the video description, download a free copy, or better yet, buy yourself a copy of the book. It's very nice. All right, and here. Okay. So I'm up and running. All right, now we are gonna basically work. Now, I want you to understand something, that when I'm doing these equations, I don't have prepared notes. I simply look at the order of questions and I try to solve them. And then I check for answers in the back of the book. See how I did. All right. So this is going to be 1.1. And then let's see here. Question 1. Is root 2 an example of rational terminating, rational repeating, or a rational number? Okay, root 2 is part of the, what is the term for rationals? Part of the real set. There you go. Let's use the real set. The reals contain irrationals, and this is going to be an irrational number. All right. 3. And here's how you know. A rational number is something that you could write as a fraction. Like, for instance, like this. But when I say fraction, I mean, like, let's say we write, let's say 1/2, right? And then you take your calculator, you go 1 divided by 2, you get 0.5. 0.5. Now, you can write root 2, and then you can go second root 2, the second function, and then it just, it's an irrational number because it just keeps going. Mine cuts off at about 10 decimals, I think. 1, 2, 5, 6, 7, 8, 9, 10, I think 11 decimals. The decimal places, but that's an irrational number. 3. Now, again, anything I say Bear in mind, I'm a student, not a teacher. If I get it wrong, I'll tell you and I'll correct it because I'm going to check the back of the book after we do the second one here. What did the associative properties allow us to do when following the order of operations? See, by the way, I mean, I have a vague remembrance of associative properties, but I need to go back and study this. There's so much to math. Okay, here we go. Associative property. Okay. Okay, this is, let's see here. Associative. Fine, let's see, we're going to say A, B, C equals to A, B, C, or if A plus C is equal to A plus B plus C. Okay. The associative property. And that's the descriptions of the properties are page 10. Let's see here. What do the associative allow us to do when following the order of operations? Okay. So order of operations is PEMDAS. That's parenthesis 2 to the n exponents, multiplication, 2 times 2 division, 1/2, 2 plus 2 addition, and subtraction. So those are, and that's the order of operations that you do them in that specific order. Basically, you go from left to right, and this is how computer code is able to execute programs correctly, is because it follows this order. To answer this question, what does the associative properties allow us to do when following the order of operations? Explain your answer. When following the order of operations, I don't even know how to answer this exactly. Let me go back, try to figure out how they want me to say it. Okay. Associative property of addition. Okay, it allows us to add okay, the associative property of addition tells us that number may be grouped differently without affecting the sum. Oh, okay, right. That makes sense. This is good for negative integers. So basically, we're going to say the associative property allows us to do this when following the order of operations. We can go, for example, 2 minus 2. We can also go 2 plus negative 2. Okay, using the associative property. All right, so basically it allows us to more easily handle negative numbers. That's how. All right, well, let's look at what the book says. All right. Download the book. You'll know the answer from getting it right before me. 1.1, irrational number, yes. The square root of 2 does not terminate and does not repeat a pattern. It cannot be written as a quotient of 2 integers, so it is irrational. Let's see here. The associative properties state that the sum or product of multiple numbers can be grouped differently without affecting the result. This is because same operations performed either addition or subtraction, so the terms may be reordered. Yeah, the sum of the multiplicative numbers can be grouped differently without affecting the result. Yeah, so, and that's what I drew over there. Okay, good. Continuing on. All right. It's 1 and 3. Okay, let's go. So we are doing odds. I'm not going to damage the integrity of the book by solving evens. Evens don't have answers, and they're used to assign homework. Sometimes they assign odds, but the answers are in the back of the book. Okay, so we have, for the following exercises, simplify the given expression. Okay, PEMDAS. Okay, that's PEMDAS right there. So we're just going to use that. So first thing we're going to do is we have to do the stuff in the parentheses. So we're going to go in here. We're going to say, now within the parentheses, PEMDAS takes effect again. So for the great equation, the whole equation, we have PEMDAS, but then inside it, the parenthesis no longer applies. So we do the exponent first. So 81 divided by 3 squared, which is 9, divided by 9. Now, notice how I write division instead of writing 1 divided by 2. This is the same as just writing 1/2. These things, they kind of get glued together, so to speak. So this could also be written as 81 over 9 or 9. Okay, and then we're going to say minus. Again, we're back to PEMDAS. 6 divided by 2 is going to be 3, which equals to -6. All right. So following PEMDAS, that should be the correct answer. 7 -2 times, okay, here we go. 16 divided by 8 minus 4 squared squared. Okay. All right. Start with the innermost parenthesis. So 8 minus 4 is 4 squared divided by 16 squared times -2. Okay, and then we have, here we go. And then, so what we have here is, now we're going to do the exponent, which is going to be 4 squared is 16 divided by 16, which is 1. Squared is 1 times -2. My answer is -2. All right. Okay, cool. All right. And, oh, something I forgot. So this is an IRL type stream. I do respond to messages. This is my normal format. You don't have to Venmo me money. If you want to, great. If not, don't worry about it. And I forgot to shout out in the comments. Hi. So the idea with how this all started with is that I wanted to bring IRL streaming to math. So the whole idea is that, I'm not prepared for this stuff. I mean, in the sense that I have the experience to do like this basic stuff, which is, I guess, basic. Doesn't mean I won't make mistakes. I'll make plenty of mistakes. But the point is that it forces me to get better at math, and you can watch me get better at math in real time. So IRL means in real life. So basically, you get to share my math journey, most of which will probably be relatively dull, but I tend to banter. And when I work as a landscaper, I watch my own videos, so I listen to my own banter. So yeah, I'm weird like that. Okay, so hold on. Oh, try it answers. There's a whole try it section. All right, well, okay, proofs and identities. This is good stuff. This is a great book. Oh my goodness, this is awesome book. I love math books. I should be wearing a glove on this hand because, any kind of sweat in your palms will mess it up. All right, here we go. Section. Okay. Okay. There we go. Hold on. -6 and -2. Good. Book agrees. All right, and I need to put something here. This is C1. Okay. All right, let's keep PEMDAS there. All right, so all right, wait a minute. We're gonna do this way. Fine. It doesn't want to do that. There we go. I'm just gonna Control X that. Okay, I'm on this layer. Okay, that's fine. Let's go to the next layer. Good. Okay, so I'm working off this layer now. All right. That's 5. That's 7. Okay, 9. What's going on here? Okay. 3, 5 minus 8. PEMDAS. Parenthesis comes first. 3 times 5 minus 8 is -3. -9. Okay. 11. 12 divided by 36 divided by 9 plus 6. Okay, PEMDAS, we have 36 divided by 9, 18, 27, so it's 4. So we have 12 divided by 4 plus 6, which is equal to 3 plus 6, 9. Okay, just double check my work. Let's see here. 12, yep. 4, 3, 9, yep. Okay. 13. 3 minus 12 times 2 plus 19. Okay. And then, so here, multiplication is the first one. So this is going to be here 3 minus 24 plus 19, which equals 2. And then we're just going to go left to right. So, I mean, either way, for division and subtraction, we'd still get addition and subtraction would get the same result either way. But that's going to be, say here, we're going to be -21 plus 19, -2. Okay. 15. 5 plus 6 plus 4 minus 11. Okay. So parenthesis plus 10 minus 11. So, and again, in this case, addition and subtraction, while they do have an order here following PEMDAS, I guess we should stick to that. 15 minus 11, which equals to +4. However, if you were to go with 10 minus 11 plus 5, here's why. The associative property, like I mentioned earlier, this is also true. Plus 10 plus -11. Right? You could also do that. That's the same thing. Which would, and then you just follow the order. So basically, we're gonna say 15 plus -11, And as you get further along, you're going to see a lot more of this, like linear algebra. Linear algebra does not have subtraction. Instead, if you are going to, this is like matrix multiplication and addition, subtraction, does not exist there. Instead, we multiply by -1, and then you add your rows. It's pretty cool stuff. At least the basic stuff, even at this level, you can do. So, yeah, I'm not an expert on it. As a matter of fact, I didn't even pass that class. I had to focus on work. So I'm doing all this stuff in my spare time. I'm a landscaper / handyman. Okay, and here we go. So we're going to do 14 times 3. Okay, so then what we have is this. 14 times 3, 3 times 4 is 12. It's 52. Wait a minute. That's wrong. 3 times 4 is 12. It's 42. 42 divided by 7 minus 6, which equals to 7 is 6 minus 6, 0. Okay, 19. All right, 6 plus 2 times 2 minus 1. 6 plus 4 minus 1, which equals to 9. Okay, 10 minus 1 is 9. 21. All right. 9 plus 4 times 2 squared in parentheses. So you do the inner parts first. 9 plus 4 times 4, which equals to 9 plus 16, which is equal to 25. All right, let's check some of these answers. Actually, let's do 27 also. And this is 21. No, I better check because I'm running out of room here. All right, let's check these out real quick. Okay. All right, let's see here. 9, -9, yes. Yes, yes. Let's see, which one is this? 17, yes. Yes, yes. So far, so good. All right, and turn that layer off. Turn this layer on. Sorry, I turned the layer off. Okay, there we go. Sorry if I'm a little sleepy. This is like my 3rd hour now streaming math. And while this stuff is not that hard, it's the intro of a course that's meant to be like for high school. So it's not too bad, but I mean, this class, you can do it at a high level high school, or you can do it in college. You do have to do trigonometry in college. I mean, at least I had to. Okay, 23. But I'm not doing it for points or kudos or a paper that says I can do it. I'm doing it because I like math. Okay, which, I'll still pursue, getting a degree eventually, but primarily in the real world, you got to focus on making money at my age. So that's what my focus is, and making money also gives me the freedom to pursue whatever I feel like it without like freaking out about college bills, because I pay for my college bills out of pocket. Anyway, don't carry a debt. Debt's bad. That is not good for you. So here we go. 25 divided by 25 is 1 minus 7, which is equal to -6. Okay. 25. By the way, I will rant on unrelated topics. It's just the way I am. You might find that infuriating or entertaining. That's entirely up to you. I'm not really a teacher. I'm just a guy. I'm a landscaper, okay? So don't ever get worked up about anything I say. I just am what I am. All right, so here we go. Now, notice here we have parentheses and we have multiplication. You could also write it like this: 2 times 4 minus 9 times -1. So this is the same thing. In this case, we're going to do the multiplication. That's going to be 8 minus. Now, the other thing what we can do is we can do this. we can take, because that we can split up that negative and carry that into the 9. So now what we have is this. We have 8 plus, let's see here, 9, which is 17. And let's check that real quick. I'm going to show you. Now, without doing all of that, let's just do it this way. 2 times 4 minus 9 minus 1. Let's watch what happens. Okay, so we have, using PEMDAS left to right, we have this 8 minus 9 minus 9. We're gonna do one step at a time to make it a little clearer. 8 minus 9, which is equals to 8 plus 9, which is equal to 17. It's not good when you have minus 9. We don't really like that in math. So that's why usually when you have that, we usually prefer plus, negative, or something like that. A double negative is a positive. Okay, so minus makes it a positive. Okay, this is 25. Let's go to 27. 3 minus 1. Okay, PEMDAS 12. 3 minus 1 is 2, divided by 6. So we have 24 divided by 6, which is 4. Okay, so far so good. All right, first let's check these, and then we're going on to the next part. So we're gonna do the fast stuff. We're gonna divide this into 2 parts. The second page, page 16, is real world applications. That we're gonna solve tomorrow. So let's just keep going and roll on through these. Check the answers first. 23 is negative 6. 25 is 17. Yes. 27 is 4. Yes. So far, so good. All right. Excellent. Here we go. All right. 29. So we have 4y plus 8 equals to 2y. We're solving for the variable. All right. So we're going to go like this. Right. So why don't we go minus 4y, and then that's going to be 8 is equal to negative 2y. And then we're going to say, divide this by negative 2, which is equal to negative 4. All right, and then we can just test that real quick. Just pop it in. 4 times negative 4 plus 8 is equal to 2 times negative 4. Okay, 4 times negative 4 is negative 16 plus 8, which is equal to, there we go, negative 8, which is negative 8 is equal to an identity. Good. All right, so far so good. And we managed to prove that without even having to check. So 31 for z. Linear algebra is also used for solving, like you have x, y, and z to solve, and you have several equations. You can solve them by you can, like, for instance, you can take the equations, and then you can write in terms of x, and then you can input that x into another equation, and then that way you can get a result, and then you can work your way that way, or just linear algebra, which is, they're both fun. And yeah, we'll get to it all. We're gonna do everything. Minus 2z. Really? You're really gonna do that to me? 1 plus 4 inside of parentheses? Okay, well, fine, whatever. So here we go. So we have 4z minus 2z times 5, which is 36. Okay, so we have 4z minus 10z, which equals to 36. So then we have negative 6z equal to negative 36 divided by negative 6 divided by, hold on. Mistake. 36. So we have divided that by -6. -6, which is equal to z equals to -6. All right, and we pop it back in. At the top, we have 4 times -6 minus 2 times -6. And then 1 plus 5 is equal to 36. So then we have 5. Okay, and then we have, here we go, -12. -12, right? Minus, and negative 20, yep, -24, which is equal to -24 plus 60, which is equal to 36. All right, we've proven that. Okay. Now, in cases where I demonstrate through proof that the variable, that the math is consistent, then we don't have to check the back of the book because we've proven it. That's the whole point about math, is that you should be able to prove something you should be able to prove something in such a way that it's conclusive. Then it's a proof. Like, there's no arguing about it. I mean, you can have like conjectures, and you can have all kinds of hypotheses, but a proof in math is something that's rock solid. That, your worst enemy can't say anything about it because it's a proof. It exists. And it is for all cases in which it applies. In other words, like, you take something that, all right, I'll show you guys a proof real quick. Right. So you have a circle, right? A sphere. Imagine a sphere. You could put 5 dots on it anywhere. There could be any kind of sphere, any kind of arrangements too. And then let's just say it was just imaginary lines. Then we have 2 on the back. So 2 in the front, 3 in the back, whatever. Actually, that's a bad drawing. It's just confusing. Let's just say that you could have here, there, here. So prove it for every case that you could always divide it in such a way with a single line around it for this circle. In other words, you can divide it into 2 hemispheres and prove that you will always be able to bisect it in such a way that you could have 4 dots in one of the hemispheres. It's guaranteed for any arrangement of dots. You can always bisect it in such a way, and this is a clean cut, right? So you're dividing the hemispheres in half, and you're guaranteed that you're going to have 4 in one hemisphere. You can guarantee that. So here's how you do it. The definition of a great circle. All right, a great circle is the widest possible circle on a given sphere. Meaning that, like, it could be, hang on a minute, it could be here, it could be here. Now, a small circle would be any other circle that you can make that's less smaller than the great circle, right? So again, you can bisect it at any angle, but the way you do this is how you prove this conclusively. You take any 2 dots that you like, and then you create a great circle around them. And any arrangement you have, because remember, this is a sphere, any arrangement you have, you could always create any 2 a great circle. And you can try this with a ball yourself if you'd like. So now what happens is, by the pigeonhole principle, where the pigeons are the dots and the holes represent the 2 hemispheres, you will always have a case where that one hemisphere could only hold, by the pigeonhole principle, one hemisphere contain at least but in any arrangement. Okay. So that's a proof. That's a sign. Box means end of proof. By great circle and pigeonhole principle, one hemisphere will always contain at least 4 dots in any arrangement of dots. Let me give you another example. Right. Suppose I said, can you come up with a name? Prove that it's possible to come up with a name consisting of 5 different letters. So you can say something like this. So, direct proof. Sandy. Okay, 5 unique letters. End of proof. That's it. Now, if I said prove that you cannot have a name that's 26 letters long. I mean, that's wrong. Let's say, let me put it this way, because there's 26 letters in the alphabet. Prove that you cannot have a unique name with 30 letters in the English alphabet. And again, by the pigeonhole principle, with only 26 letters in the alphabet, you cannot have a 30-letter name that's each letter being unique, because you simply run out of letters, right? So this is what math actually is at a high enough level. You do proofs, and you prove it for every kind of case of its type. So just like with the hemisphere, proving by great circle and pigeonhole principle. But getting back to what we were doing here, so that's what math is about. But these are tools that we're learning right now. Okay, where was I at? I was solving for 33. Like I said, this is I go off on wild tangents. Just expect that. So parenthesis, and first thing we're going to do is exponents. So 2x squared is 2x times 2x, which is going to be 4x squared. Negative 4x squared plus 1 is equal to negative 3. Okay, now what we have, let's rewrite this. Negative 4x squared plus 1 is equal to negative 3. And we're going to say, you know what? Let's flip everything around. We're going to move plus 4x squared plus 3 plus 3 plus 4x squared. So basically, hang on a minute. Did this right? Yeah, that should be right. So this becomes 0. This becomes 4. This becomes 0. And then 4x squared is equal to 4 divided by 4 divided by 4. So 1 is equal to x squared. When you have a square, then the answer is going to be 1 plus minus, sorry, I wrote that wrong. X equals to plus minus 1. Or we can say x is equal to -1 and 1. Okay? And the parenthesis, this is just like an ordered set that we have here. But yeah, this would work. And then either one, if we, let's find out. Let's see what happens. Let's take the -1 first. Let's see here. -2 times -1 squared plus, I'm running out of room. See if I can move this anywhere else. Okay, let's do it right here at the bottom. So we have so 2 times -1 squared plus 1, -3. So then we have the interior parenthesis first. So, by the way, I threw that around -1, and that's because it's a multiplication. You automatically put it up when you have a negative like this on the inside. It's just otherwise, it's hard to explain what the multiplication is going on. So we're going to say this is going to be, but it's fine. It's the way how to do it. -2. We're going to square that first, plus 1. So that's going to be 4. Negative plus 1, which is equal to -3. -3. -3. Now notice if this right here, and if this wasn't negative, if this was positive, this would have been 2 squared. Still would have been -4 plus 1. And then that still would have been -3. So it all adds up. Yeah, so the answer is correct. This is correct. I have proven it. Here we go. Next, let's go to 35. 11C minus 4. You could use any letter you like to stand in. Usually we use A, B, C, W, X, Y, Z. I, J, K also. Depending upon the types. I, J, K is primarily used for vector spaces. X, Y, Z is just for regular stand-in numbers. Also A, B, C. So, but yeah, it's fine. Okay, so let me make sure I wrote this right. Yeah. So we're going to cross multiply. This is going to hit both of them. 22C minus 8 is equal to 36 plus 8 plus 8, which is equal to 44. 22C divided by 22, 22. C is equal to 2. Okay? And then we pop it back in. 2 times 11 times 2 minus 4. Allegedly is 36, so we're going to have 22 minus 4 times 2 allegedly is 36. And then we have, there we go. Okay, so that's going to be 18 times 2, which is 36, which is true. 36 is equal to 36. Nice, nice. Okay, and here we go. We get our first fraction. 37 1/4. 8W minus 4 squared equal to 0. Okay, so here we go. Right. So PEMDAS. So we're gonna go like this: 1/4. 8W minus 16 equal to 0. So then we're gonna multiply both of them, which is equal to 8 over 4. That's gonna be 2W minus 4 equals to 0. Plus 4, which is equal to 2W is equal to 4 divided by 2 divided by 2. W is equal to 2. All right, and we pop it back in. 1/4. 8 times 2 minus 4 squared is equal to 0, which is equal to 1/4 times 16 minus... looks like I made a mistake somewhere. Yeah, I made a mistake. See, this is why you pop it back in. All right. What did I mess up? Let's try it one more time. So 8 divided by 4 is 2. 16 divided by negative 4. Okay. So then we have, here we go. Then we have 2w minus 4, which is 2w equals to 4, divided by 2w is equal to 2. 8 times 4 is going to be, 8 times 2 is 16, minus 16, that would be 0. Oh, no. I'm dumb. This is correct. We're trying to get to 0. I was like, well, usually when you have a case like that and you have a number, like if you have like 2 equals 0, right? That's a contradiction. You know you made something wrong, but we're trying to get to 0. So we have 1/4 times 0 equals 0. Anything times 0 is equal to 0. So that's true. Good. All right, then we have to simplify a few equations. All right. Okay, so let's try this. 39. Okay, 2y minus 4. So basically what we do is we're going to perform operations till we can't perform anymore. Yeah? So we have 2y. Actually, let's just do them in order in the line. Say 2y. Now, this isn't, the square only applies to the 4, not to the y also. That could sometimes, but not in this case, which is minus 16y minus 11. So then all we can do is we can add these two, the two y's. So we're going to get negative 14y minus 11. That's it. There's no equation beyond that. There's nothing to solve because we would have to have an equals. So that's the only solution. So continuing. I'll have to check those ones, but okay, so then we have 8b. So the 3. So in this case, the b is not a, okay. The 3 is not an exponent. So there are 4 b's basically, and we want to increase it by 3. So it's going to be 12 b's, but negative 12 specifically because there's a negative in front of it, plus 1, which is equal to negative 4b plus 1. Okay, 43. All right. 7z minus 3 plus z times, don't forget PEMDAS, 6 squared. Okay, so first thing we're going to do, I'm just going to do it not in line, but I'm just going to go down here. Actually, you're not going to do it. I'll do it down here. So we're going to say 36 times 2 plus minus 3, and then 7z. Oh, shit. No. I'm sorry. I messed this up. That's a z. Okay. That's a z. Z times 36 plus negative 3, 7z. Okay. Z's and 2's are easy to confuse. That's why you can do the strike in the middle like that. 7z minus 3 plus z 36. Okay. So that equals to 7z minus 3 plus 36z. Okay. Which is going to be, we're going to say 43z minus 3. Okay, that should be right. Okay, let's double check that real quick. Yeah, it looks right to me. But I will double check the answers in the back of the book. 45, 9, y plus 8, minus 27. All right, so then we're going to distribute. Now, this is a distributive property that we're using right now. We're going to distribute the y like this. So we're going to say 9y plus 72 minus 27, which is equal to, okay, I gotta take a second here. I'm at risk of making an arithmetic error here. Okay, 45. 9y plus 45. Okay, and 47. 6 plus 12b minus 3 times 6b. All right. PEMDAS. Okay, minus 18b. All right. And that's going to be, so we're going to say negative. Okay, 6b plus 6. We could actually pull out the 6 if you wanted to, but that's fine. We could also do this if you wanted to. We can say 6 times, we're going to say negative b plus 1. You can do that too. So I factored out the 6 basically. You could argue that that's a more simplified form. But I don't think that's the one they're going to want. Because we have, like, if you look at 45, the 9 has been factored out, and they're simply putting it back in. So we're not going to factor out any numbers. We're sticking to what the simplification here works. Okay, that's so far so good. 47, 49. Okay, and 49 for 9 squared times 27x. Okay, so basically what we're doing is we are multiplying. When you have a square, you're multiplying both. It's basically, you could think of it this way. 4/9 times 4/9 times 27x. You could think of it that way. Which is equal to 16 over 36 times 27x. Okay, so we can factor out 4, or we could reduce it by 4. Simplify by 4, I mean. So we're going to say 4 over, okay, I'll start there. Which is going to be 9, 4/9. Wait a minute. Okay, oh, no. I'm just getting tired. That's where I made a mistake. It's 81. There we go. Times 27. That makes a lot more sense. So now, basically what we have is, let's see here, 27. We can go 3s. Let's pull a 3 out of here. So this is 9, 3, 81 divided by 3, 27. Oh, never mind. We're going to divide it by 27. Okay, there we go. So 3, which is equal to 16 third x. All right. So yeah, that's good. Um, let's see here. That was 49. And we have 51. Now we have 51. And then 51 is going to be, actually, let's see here. Shine a little bit more light on this thing. Okay, let's try to stick it down here, 51. 51. Yep, we got room. 9x plus 4x 2 plus 3 minus 4 2x plus 3x. Okay, we are just simplifying. PEMDAS, parenthesis. So we're going to say 9x plus 4x times 5. 2 plus 3 is 5 inside the parenthesis. Minus 4. Well, I could speed up and do several operations at once. Ideally, you stick to one type of operation. In this case, I'm starting with the parentheses and doing that first. If you do too many operations, it's easy to make a mistake or get lost. So, starting with PEMDAS, we're starting with parentheses, we did that. So 2x plus 3x is 5x, and 2 plus 3 is 5. And then we do multiplication. 4x plus 20x minus 20x, which is equal to 9x. Okay. Distributive property, right? Notice how the parenthesis, the x had been factored out. The x, this x right here, they simply factored it out. They went zit, pulled it out and put it right there. So that's what happened there. That's how we ended up with both 20x's. They're trying to show us how all this stuff works. You see what I'm saying? All right. We're going to call this section 1.1-1. And then tomorrow we'll do 1.1-2. And then that's just a few real world questions in the back. Save that for tomorrow. All right, let's first check to make sure if I made any mistakes on the simplification. All right. By the way, if you downloaded the book, you can check for yourselves. Don't take my word for it. Yes. Yep. All right. So far, so good. This book is coming along. Exciting. Good book. Get the book. Support the company. Get the book. Support this OpenStax idea. You know, why spend hundreds on textbooks when you have OpenStax? Anyway, I've used an OpenStax book for one of my courses for Calculus 2. I'm actually, it was a Calculus 3. But anyway, I have the whole set of Trigonometry, Calculus 1, 2, and 3. And I'm sure there's other books that I'll probably be going through. So, yeah, this is good for me. This is good for me to practice this stuff. I hope you learned something. If you didn't, that's okay. The one thing, the big takeaway is that do the work. Simply watching videos, you'll maybe have a 10% retention rate, if that. But if you struggle with it yourself, you're going to get a lot more out of it. Anyway, I usually stream after work. I start at pretty much a daybreak, go to work, and then I work till dark, sometimes past dark, depending upon what's on my schedule. And then afterwards, I come here and stream. So, yeah, I look forward to seeing you again next time.